Today we have to complete this chapter, okay?
Okay, sir.
Look, in the last class we have discussed about change, chemical change, reaction and their characteristics, and also complete balancing and a need to balance a chemical equation. Okay.
Uh,
So, so change is of many type. Okay. So on the basis of a chemical composition, on the basis of a chemical composition or chemical buildup, change is of two types: physical or chemical. If chemical composition is changing, that means chemical. If no, then physical. Okay. Then we
okay,
understand
sir.
when physical change occurring, that means only change in physical properties like shape, size, physical state. Okay, like breakdown of a paper. Breakdown of a paper is a example of a physical reaction, physical changes. Then come to chemical change. Chemical change means change in chemical composition, like burning of a paper. Okay, burning means it is a process when one substance react with the oxygen, okay, to give the products, and heat and light energy is released. The process of a chemical change is known as chemical reaction. The process through which chemical change is occurring, that process is called chemical reaction. So here are some example of a chemical change and physical change. Physical change means only change in a state, shape, or a color. Or physical chemical change means change in composition. Then we understand characteristics of a chemical reaction. Characteristics is nothing but to identify whether a chemical reaction is happening or not. Okay. Number one, change in color. Number one, change in color. The change in color shows whether chemical reaction is occurring or not. Okay. Hello. Hello.
Hello, sir.
Yeah. Look. Change in color, formation of a precipitate. Precipitate is nothing but white insoluble solid. Okay. Then we understand evolution of a gas. When chemical reaction happening, that time gas is also released. Okay. These are the
Okay, sir.
example already we have covered. Change in physical state. Physical state means, look, baking soda which is in solid, vinegar which is the aqueous. Aqueous is nothing but dissolved in water. Dissolved in water.
Water.
Anything dissolved in water is called aqueous. Look, baking soda is solid, vinegar is aqueous. But look the product, we get water that is in liquid form. We get carbon dioxide that is in a gaseous form. So physical state is changing or not? Okay.
Uh,
Then we understand change in temperature. Change in temperature, two types. On the basis of change in temperature, chemical reaction two types. One is exothermic, one is endothermic. Exothermic means exothermic means energy released to the surroundings. Endothermic means release observed by the energy observed by the reaction. Okay.
uh,
Then we learn burning of a natural gas is one of the example of a exothermic. Exothermic means heat energy released to the surroundings.
okay, sir.
Respiration is also a example of a exothermic. Then
Okay, sir.
then conversion of a green matter to fertilizers is also a example of a exothermic. Then but photosynthesis is one of the example of a endothermic. Okay. Hello.
Okay, sir.
Okay. Endothermic means heat is observed by the reaction. Then we understand balancing and need of a chemical equation. We already covered this. Then move to our concept.
Uh,
These things we covered in the last class. Limitation of a chemical equation. Okay.
okay, sir.
Catalyst. Catalyst is of a two types. Catalyst means any substance that increase or decrease speed of a chemical reaction. Okay. Positive catalyst, negative catalyst. Positive catalyst means it increase the speed. Negative means it decrease the speed. Okay.
Uh,
Come to types of reaction. Come to types of a reaction. In
yes, sir.
in this class, particularly we are trying to cover types of reaction. One is combination. One is a
Uh,
combination. Second one is decomposition. Second one is a
chemical.
decomposition. Types of a reaction. Types of a chemical reaction. One is combination. Second one is a decomposition. Third one is a third one is a third, fourth, fifth. Just wait. Displacement. Third one is a displacement. Fourth one is a double displacement.
Hello,
Fourth,
sir.
yeah. Fourth one is a double displacement. Is my voice clear?
Yes, sir.
and fifth one is redox. We have to cover these 5 types of a chemical reaction: combination, decomposition, displacement, double displacement, redox. So first one is combination. First one is
Combination.
combination, or we can say synthesis. Two names are there: combination and synthesis chemical reaction. So what do you mean by combination? Combination is nothing but a chemical reaction in which two or more element or compound. Element, how many element are there? How many element? 1118 element
118.
in the world. Element means pure substance. Hydrogen, helium, lithium, these are the element. Compound means group of a element. Group of a
Element.
element. So this reaction is telling two or more element or two or more compound are react with each other to form a single compound. That means suppose A is a element, B is another element, they react with each other to form AB. This is a combination. Suppose A is AB is a compound and CD is another compound, they combine each other to form ABCD. Okay. Two two element combine each other to form compound, or two compound combine each other to form compound. Okay, single compound. Remember, two element or two compound, but product should be single compound. Product should be single compound. This is called combination reaction. Combination reaction are of following types. If you are taking two element, okay, that is called a combination of a two element to form a compound. Two element to form one compound.
Form a compound.
Then two compound to form a compound. Two compound to form a compound. Product should be one. Product should be one. Okay. In combination reaction, how many reactant don't worry. The reactant may be compound, may be element, but the product always should be one, and that is one compound. Okay.
Okay.
Then third one is combination of an element and a compound to form a compound. This one is not in your syllabus, so you have to focus on this. Means element plus element to form a compound, compound plus compound to form a compound. Okay.
Okay.
Look, first we have to understand element plus element to form a compound. Element plus element. Okay. Two or more element are reacting each other to form one compound. One compound.
Compound.
This is nothing but your combination reaction. Look, two example I am taking. Two example. Burning of a magnesium oxide. Burning of a magnesium. Burning of a magnesium. So burning means any substance react with oxygen. Any substance react with oxygen to form product, and heat and light energy is releasing is called burning. Okay.
Ah.
Magnesium is nothing but a metal. Magnesium is nothing but a metal. Metal have a tendency. Metal have a tendency to always react with the oxygen, nitrogen. Okay, to form their oxide. To form their oxide. So, where two condition. This is the example of a combination reaction. Okay, two conditions are there. At room temperature, the burning of magnesium is one type. When we provide heat, that is another type. Okay. What is happening at 25 degrees Celsius? 25 degrees Celsius is called room temperature. If someone asks the question, what do you mean by room temperature? Room temperature is nothing but 25 degrees Celsius. At 25 degrees Celsius, what happening? Look, magnesium in air, oxygen is present. Magnesium react with oxygen to form magnesium oxide. To form magnesium oxide. Here, no heat and low light energy is decreasing because it is a slow reaction. It is a slow reaction. Look, magnesium is a element. You know, magnesium is a element. Oxygen is another element. Look, element plus element to form a compound. Magnesium oxide is a compound.
Yeah.
So look, first this is the skeletal reaction. This is the skeletal reaction. We have to make it
Combined.
balanced. Look, how many magnesium atom are there? One.
One.
Here, one. Here, how many oxygen?
Two.
This side.
One.
So make it two. Now oxygen is balanced. Look, magnesium here two, here only one. Make it two. Okay. This is the example of a combination reaction of a magnesium ribbon at room temperature. Actually, what happening when you keep magnesium in front of air, they react with oxygen because oxygen is available in the air, na? They form one white color coating on its surface. Coating on its surface. This white color coating is nothing but magnesium oxide. Nothing but magnesium oxide. Okay?
uh,
It, maybe the question is coming like this: when magnesium react with oxygen at room temperature, what happening? You have to write magnesium oxide is creating with a white color coating. Okay.
good.
But second thing is we have to change the temperature. We have to change the temperature here, room temperature, but here we have to provide temperature. What happening here? Look, same reaction is same. Magnesium plus oxygen. Remember, most of the metal are in solid state. Okay,
Okay.
magnesium plus oxygen. Here also magnesium oxide is creating, but with this heat energy plus light energy plus light energy also increasing, releasing. Here only magnesium oxide, but here when you provide external heat, it forms magnesium oxide, heat and light. This light is a dazzling light, means bright color light. Okay, and look, heat is releasing, so it is a exothermic reaction. It is a exothermic
Yeah.
reaction. So look, element element form one compound na?
Yeah.
This is the example of a combination of two element to form a compound. You have to remember these two. Okay, remember, before hitting the magnesium, you have to clean the magnesium ribbon. Why? Because
It will not burn.
because
Oxide.
it contain one external coating it. Okay, you understand? One type
Yeah.
element plus element to form a compound. It is one type of a combination reaction. Okay,
uh,
then come to uh, such a important question. Why is it advised to wear eye protection during the burning of a magnesium ribbon? If you do the reaction, what happening? Look, magnesium plus oxygen plus oxygen. This is happening when we provide external heat. Okay,
mm,
magnesium oxide plus heat plus light and make it balanced. Two, two. Then provide the description. It is solid. It is a solid. Oxygen is a gas. Magnesium oxide is a solid. Okay.
mm.
So
Yes.
look, when this reaction is happening, you have to advise to wear eye protection like spectacles. Why? Why it is saying? Because the light is dazzling bright white color light. Okay. So look, when magnesium ribbon burns in air, dazzling white light is produced. Which type of light? Dazzling white light.
Yes.
Okay, which contain ultraviolet light. Ultraviolet light means it is harmful to our eye. It is harmful to our eye. That's why people are saying don't look towards the sun without naked eye, sorry, with naked eye. Okay, whenever you are doing this, you have to use spec. That can causes photokeratitis is nothing but temporary painful condition of eye. Okay, or it can permanently damage the eye. Directly question last year came from this. The why it is advised to wear eye protection during the burning of river magnesium? Because during this reaction, dazzling white light is produced. This contain ultraviolet light. This can cause photokeratitis. Photokeratitis is nothing but temporary painful condition of our eye. Okay, that's why it is suggested that you have to use eye protection. You have to use eye protection like spec. Okay,
Uh,
then come to one type we complete. Second one is a compound plus compound plus compound gives you another compound.
uh,
This is the combination reaction because product is one. Product is a one. So look what happening. AB, suppose AB is a compound and CD is another compound. Okay, they combine with each other, they react with each other to form ABCD. You understand or not? It is one type of a combination reaction where
Yes.
two compound are react with each other to form a compound. Okay, so example is look quicklime, calcium oxide whose symbol is calcium oxide.
Oxide.
Calcium oxide have two name. One is quicklime, one is a quicklime, and another one is a brunt lime. Brunt lime. You have to remember the common name. These are the common name, and the scientific name is chemical name is calcium oxide. Calcium
Ah.
oxide. So the calcium oxide, otherwise we can call it as quicklime. Okay. When react with water, they give you calcium hydroxide. Calcium hydroxide.
Ah.
Focus only on this reaction. Look,
Oh.
calcium oxide is a compound. It contains calcium and oxygen.
Okay.
While water is also a compound. It contains
Ah.
hydrogen and oxygen, and it gives you calcium hydroxide. Calcium hydroxide is also a compound.
Hmm.
Look, two compound react with each other to give you one compound.
Compound.
Look, and this calcium hydroxide is called as sec lime. It's called the
Settling.
sec lime. You have to remember this common name. Quick lime or burnt lime is the general name of a calcium oxide, but
Hmm.
calcium hydroxide is the slack lime is the common name of a calcium hydroxide. This is nothing but calcium hydroxide. Okay.
Okay. Ah.
Okay. Look. Generally, you have to remember calcium oxide is nothing but a metal oxide. Metal oxide means calcium is a metal. Ox it reacts with oxygen to form calcium oxide. Look, some metal oxide are soluble in matter. Not only calcium oxide, sodium oxide, potassium oxide, calcium oxide, magnesium oxide. These are soluble in water. Means when you react with water, it gives you it's a hydroxide form. Okay, you understand?
Yeah.
From this page, you have to remember three things. One is this reaction. One is this reaction. Second one is quicklime and brunt lime is the common name of calcium oxide, and slaked lime is the common name of calcium hydroxide. Okay,
Ah.
and then look. Actually, when this reaction is happening means when calcium oxide react with water. When calcium oxide react with water to give calcium hydroxide to give calcium
Ah.
hydroxide. Look, calcium oxide solid form, H2O gaseous form, sorry liquid form,
Okay, sir.
and calcium hydroxide aqueous form. What happening? Look, some things, some observation you have to look. Number one, very fast reaction. When calcium oxide react with hydrogen or sorry react with water, it is such a fast reaction. Okay,
Okay, sir.
heat is evolved. That means plus heat. Heat is evolved means it is exothermic reaction. Okay, water boils to form steam and produce a hissing sound.
Ah.
Then what happening? Due to this heat, the water boils. Okay, and they form steam. Steam is nothing but a gaseous form of water, and produce a hissing sound like this type of sound. Okay, these three things happening during the quicklime react with the water. Okay,
Ah.
and tell me it is a exothermic reaction because heat is released to the surroundings. You understand this?
Hmm.
And then what happening? Look, it is not comes under combination reaction, but it is a common example. Look, white was a limos. Look, after 2 to 3 days of whitewash or lime wash, what happening? Look, this calcium hydroxide, this calcium
Hydroxide.
hydroxide, which is called sec lime, which is called the sec lime. This is what we use in our paint. When painting, we use this in our room. It is white color. It is white color. When this react with carbon dioxide, when this react with carbon dioxide, it forms calcium carbonate. It forms calcium carbonate and water. Water evaporates, and due to this calcium carbonate, our walls shine. Okay, this calcium carbonate common name is marble, limestone, chalk, excel. Marble, why marble is shining? Due to because it contain calcium carbonate. Why limestone is shining? Because it contain calcium carbonate. Why chalk is shining? Because it is made by calcium carbonate. Okay, so three things we learn here. One is calcium oxide, which is called burnt lime or quick lime. It is called quick lime or a burnt lime. Okay. Second one is calcium hydroxide. Second one is calcium
Okay.
hydroxide, which is called sec lime. Sec lime. And third one is calcium carbonate. Calcium carbonate. These are the common name. First, when you react calcium oxide with water, it give you sec lime. When you react this sec lime with carbon dioxide, it give you calcium carbonate. Okay, our marble, limestone, chalk, excel, all are example of a calcium carbonate. It contain calcium carbonate. That's why they are shining. Okay. Then the question is, sir, look all these reaction. Look all these reaction. When burning of a ribbon, when we provide heat, look, it also produce heat. It also produce heat. That means it is exothermic. It is a exothermic reaction. Okay. Then look here. Here also heat is produced. Here also heat is produced. That means it is one exothermic. That means the question is, sir, the question is, are all combination reaction exothermic? No. No. The answer is no. Not all combination reaction are exothermic. They can be endothermic. They can be endothermic. Look here. Here one example is given. N2 plus O2. Look, N2 is a element. O2 is a element. They combine each other to give nitrogen monoxide. Nitrogen react with the oxygen to give nitrogen monoxide. Okay. So balance this. Balance this. Here how many nitrogen? 2. Here 1. Now it is balanced. Now it is balanced. Look. To 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 do this reaction. To do this reaction, we require heat. We require heat. So look, one product, two elements are combining each other to form one product. That means it is a combination reaction. It is a combination reaction. It is a combination reaction, but heat is observed. That means are all combination reaction exothermic? It's no, na. Because look, here is one example of a exothermic reaction. Sorry, one combination reaction which is endothermic. Which is a. Are you understand? So look, the above reaction takes place when heat energy is provided through lighting. Look, in air, nitrogen is available. In air, oxygen is also available. So when lighting is happening, it get heat. It get a heat energy, and it form nitrogen monoxide. Nitrogen monoxide. Nitrogen is a gas. Oxygen is a gas. Nitrogen monoxide is also gas. Here heat is observing, so it is a endothermic reaction. Endothermic Okay, with this we completed combination reaction. Combination reaction means two or more element or compound combine each other to form a single product. To form a single product.
हाँ.
Okay, you understand? Or have you any doubt?
No, sir.
Then come to the next, that is decomposition. 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 Reaction.
हाँ.
Sir, it is exactly inverse of a combination reaction. Sir, what happening in combination reaction? Two element, two or more element, or two or more compound to form single product, single product, single product. But here reactant should be single. Reactant should be single. Product, product, many. Okay.
हाँ.
A chemical reaction in which a single compound break down into two or more element or compound. Break down into two or more element. This is a compound. This is a compound. AB is a compound. It break down into two or more product. Okay.
Okay.
When energy is supplied, so why how this is happening? When you provide energy, to break the bond, okay. To break the bond between one compound, we have to provide energy externally. The energy in form of a heat, the energy in form of electricity, the energy in the form of sunlight. Okay.
Okay, sir.
So, a chemical reaction in which a single compound breaks down into two or more elemental compound when the energy is supplied. Okay, and the energy may be heat, electricity, or sunlight. Okay, here a B is a compound. It breaks down into two elements when we provide heat, electricity, and sunlight. Okay,
Hmm. Okay, sir.
okay. Like composition reaction, decomposition is of three types. Decomposition is of three types. When you provide heat to break down the compound into element, this is called thermolysis. This is called the thermolysis. When you provide electricity, it is called electrolysis. When you provide sunlight, it is called photolysis. Okay. Based on the energy supply in a decomposition reaction, we have three types of decomposition reaction. One is thermolysis. Thermo means heat, lysis means breakdown. Electrolysis means electric current breakdown. Okay, by the help of electric current, electricity, we break down the compound. Photolysis means by the help of sunlight, we break down the compound into element. Okay.
Okay, sir.
So first we have to take one example of a thermolysis or thermolytic decomposition. Thermolysis or thermolytic decomposition means we require heat energy. We require
Heat
heat
energy.
energy to break down the compound. So look, thermolysis of hydrated ferrous sulfate. Hydrated means ferrous sulfate with water molecule. Ferrous sulfate with water molecules. Look, iron is a element that have a two valency. One is Fe2 plus, one is Fe3 plus. Like copper, copper is also Cu1 plus and Cu2 plus. Okay.
Okay,
Look,
sir.
we we connect OUS or RIC. Look, if higher valency, we use RIC. If lower, we use OUS. That's why ferric. Okay. So here also cuprous and cupric. Okay. You have to remember there are some element that having dual valence. Okay.
Hmm.
The ferrous is a element that having two valence. One is Fe2 plus and another one is Fe3 plus.
Fe3 plus.
Fe2 plus is called ferrous and Fe3 plus is called ferric.
Ferric.
So here we are taking ferrous means lower valence. Ferrous sulfate. This is the symbol of ferrous sulfate SO4. Okay. Hydrated means connect with water molecule. Connect with a water molecule. How many water molecule we require? 7. How many we require? 7. Look. This is the ferrous sulfate compound. Hydrated means .7H2O. Means ferrous sulfate with 7H2O we called hydrated ferrous sulfate. Okay.
Okay, sir.
Here we are learning which type of decomposition. Thermolysis means it is a compound. Na? It is a compound.
Come.
We have to provide heat energy because we read under thermolysis. When you provide heat, heat can be written as delta also. What happening? Look. First look the reaction. Ferrous sulfate FeSO4 .7H2O. It is pale in color. Look, this is the ferrous sulfate. Are you looking?
Yeah.
This color. When you provide heat, okay, this is the solid. This is a solid. It break down into ferrous sulfate plus water. Ferrous sulfate plus water. Ferrous sulfate is a solid and water is a gas. Sir, why gas? Because we are giving the heat, na, and the water is converted into steam.
Steam.
Okay, that is the gaseous form. So look what happening. One compound break down into several compound when you provide heat. That means it is a decomposition reaction, na?
Hmm.
Decomposition reaction means it is a reaction in which a single compound is break down into many compound or many element. Okay.
Okay.
So look then, if you again provide heat to this ferrous sulfate, what happening? This ferric oxide and sulfur dioxide and sulfur trioxide is creating. Look, what is happening? Try to understand. First, we have one compound hydrated hydrated ferric sulfate. It is solid. It is a solid and its color is a pale green. Pale green.
Hmm.
Okay. When you provide heat, it break down into ferric sulfate plus water. Ferric sulfate plus water. Then look, for balancing, we are using 7 here. So this ferrous sulfate is white color. Is a
Hmm.
white color and it is a solid. It is a solid. Are you looking? Then what happening later? If you give heat to this ferrous sulfate, it is also breakdown into ferric oxide plus sulfur dioxide plus sulfur trioxide. Okay, and this ferric oxide is reddish brown in color. Look, this is the color of a ferric
Ferric.
oxide.
Ferric.
Okay, so you have to remember this example. Okay,
Okay.
have you any doubt here?
Ah.
Have you any doubt?
No, sir.
This is thermolysis. This is a decomposition reaction because look, single compound is breakdown into
Three or four.
many product.
Many.
So it comes under decomposition and we require heat. So it comes under thermolysis or thermolytic decomposition. Okay.
Okay, sir.
Then come to precaution. While doing this, you have to do some precaution. This is your NCERT book image.
Ah.
Okay. What is the precaution means? During
So,
uh, during during the reaction, you have to do something. Okay. Number one, do not point the mouth of the boiling tube at your neighboring or yourself. Look, this is the point. Okay, this is the boiling tube. Okay, don't you put the opening to your side or your friend's side. Okay,
okay, sir.
then number two, waft the gases. Don't sniff them. This is done to confirm the presence of a sulfur dioxide and sulfur trioxide gas released. Look, what is it is saying? Look, in chemistry, sometimes we are smell the gases to understand to know which type of gas is releasing. Okay, so in this reaction, first I'm writing the reaction. Look, first hydrated ferrous sulfate is boiling to form ferrous sulfate plus water plus 7 is to water. Then again boil this. Ferrous sulfate. It will give you ferric oxide. Just a minute. Ferric oxide plus sulfur dioxide plus sulfur trioxide. Look, this is the entire reaction. Number one, heat, you are giving heat to the reaction, na? So that means it is boiling. So during boiling, don't point the mouth of the boiling tube. Look, this is the boiling tube. Don't give the mouth of the boiling point toward yourself and your friend side. Okay. Then warp the gases means don't smell directly. Don't smell directly. Try to smell by using your hand. Okay. Okay. So smelling. Why you require smelling? Because smell of a gas is a reliable way to detect evolved gas. Look, here sulfur dioxide and sulfur trioxide is creating the.
Yeah.
So this smell is same as when burning a matchstick. When a matchstick is burning, the smell that is similar to sulfur dioxide or sulfur trioxide. That means by smelling this, you can understand yes, sulfur dioxide and sulfur trioxide is releasing. Okay, but don't smell directly. Smell means put the tube towards to, to towards other side, and by your hand put the air to your nose. Okay. Then third one is always use a test tube holder while hitting the tube. Look, the girl is hitting the girl is carrying the test tube by using one test tube handler. Okay, this is the precaution while you are doing this reaction. Then come to then another example. Another example under thermolysis decomposition. We are learning decomposition reaction. Decomposition reaction means single compound breakdown into many products. Okay, this is happening in presence of a heat, electricity, and a sunlight. If heat, it is called thermolysis. If electric current, electrolysis. If sunlight, photolysis. Okay, so look. Another example is thermolysis of a calcium carbonate. If you remember calcium carbonate, this is the symbol. And the common name is marble chalk limestone. Few seconds ago we have did this reaction. When calcium hydroxide react with the carbon dioxide, that time we form calcium carbonate. Okay. Actually, what happening when you give carbon calcium carbonate is solid. When you provide heat, it will break down into calcium oxide and the carbon dioxide Okay. This carbon oxide is called quicklime, na? So why it called it bronze lime? Because look, when we heat the calcium carbonate, then only we get calcium oxide. That's why it is called bronze lime. Bronze lime means it is heating when we heat when we heat calcium carbonate, that time calcium oxide is formed. Due to heat, its name is bronze lime. Okay? And remember, this calcium oxide is one of the important component in the cement industry. One of the important component in the cement industry. You understand this?
Yes.
Then come to another example, thermolysis of lead nitrate. Thermolysis of lead nitrate. Remember, okay. There are some metal. Metal means we will understand completely about metal. For this, only one thing you remember. Metal means who donate electron. Element who donate electron easily. To form positive ion. To become positive ion called metal. Calcium, magnesium, aluminum, zinc, iron, lead, copper, gold. These are the example of a metal. Metal nitrate. When you heat metal nitrate, that time they gives you metal oxide, nitrogen dioxide, and oxygen. This is also one example of a thermolysis or thermolytic decomposition. Look, this is lead nitrate. This is lead nitrate. Lead is a metal. Lead is a metal, and this is a nitrate. This is nitrate. Okay,
Okay.
it is solid. It is solid, and its color is white. When you heat it, look, it is a compound. Na? It is compound. Na? When you provide heat energy, it breaks down into lead oxide. It is lead oxide. It is lead oxide,
Hmm.
nitrogen dioxide, nitrogen dioxide, and oxygen. And oxygen. Look, single compound breakdown into many product. This is nothing but your decomposition reaction, na? And it is happening in presence of heat, na? That's why it is thermolysis. Okay.
Hmm. Ah.
Then during this reaction, something you observe. What you observe? Look.
Ah.
Number one, a cracking sound is heard while thermal decomposition of a lead nitrate, and this process is known as a decrypitation. So, okay, while you doing this, while you doing this reaction, okay,
Ah.
when you doing this reaction, you will listen one cracking sound, like listening one cracking sound, टूटने की आवाज. Okay, why you are hearing this sound? Because when
Hmm.
thermal decomposition of a lead nitrate, you heard one sound. This is called decrypitation. Okay,
Okay.
one brown fumes of nitrogen dioxide are evolved. Remember, this nitrogen dioxide is in brown fumes color. Okay, the number three,
Hello.
a yellow residue of a lead oxide is left behind in the test. Residue means anything left after reaction. Okay,
Okay. Ah.
lead oxide is brown when hot, yellow when cold, and stick to the glass tube. Remember, when the when lead oxide is in heat, that is brown in color. Now when it is cool down, it becomes yellow.
Ah.
So three things you have to remember while during this reaction, while during metal, while during
Hmm.
while lead nitrate, you have to do the thermal decomposition. Then you will get lead oxide, nitrogen oxide, and oxygen. Okay, and you hear some sound. The sound is because due to decomposition of a lead nitrate, and you will get residue which is yellow in color, and brown fumes, nitrogen oxide and oxygen gas is released. Okay, you have to remember these three example of a thermolysis. One is thermolysis of a hydrated ferrous sulfate, and another one is thermolysis of a calcium carbonate, another is thermolysis of a lead nitrate. You understand this? Hello. Then come to next, thermolysis of a copper nitrate. Same thing, metal nitrate, same. Copper nitrate, copper oxide, and nitrogen oxide, oxygen. Here copper oxide is black in color. Okay.
Ah.
Then come to electrolysis. Second type. If you remember, the decomposition are of three types. One is the uh,
Hmm.
one is thermolysis, another one is the electrolysis, and third one is the photolysis. So what happening in electrolysis? Look, water. When we give electricity to the water molecule, it breaks down into hydrogen and oxygen. It breaks down into hydrogen and oxygen.
Oxygen.
This is happening. Look, water is a compound. Water is a
Compound.
compound, and when we give electrical energy, it is converted into hydrogen and oxygen. It is converted into hydrogen and oxygen. So look, this is the element. This is the element. This is nothing but example of a electrolysis decomposition. So look this setup. What happening here? Look how to do this. First, in a beaker, you have to carry some water. Okay. Then you have to put some graphite rod. Put some graphite rod. Graphite is a carbon compound, that is that is good conductor of electricity, good conductor of electricity. So when you keep first you have to put water inside one beaker, then you have to put graphite rod. Okay, connect to the positive and negative terminal of a battery. Okay, the graphite rod that connected to the positive terminal of a battery is called anode, is called the, and the graphite rod that connected with the negative terminal of a battery is called cathode, is called the cathode. When you pass current, current through this graphite rod, what you observe, look, some reaction occur, breakdown of water. uh, at cathode you will find hydrogen, and at anode you will get oxygen. Okay, then during this reaction we have to use acidulated water or sodium chloride added to water. Why, sir? Why during electrolysis of water we require acidulated, means you have to mix acid with that water, otherwise sodium chloride. Why, sir? These two are called electrolyte. These two are called electrolyte. Electrolyte means breakdown into ions. Easily break down into ions. This acid and sodium chloride is called electrolyte. Why you require electrolyte to electrolysis of water? Because look, water ionized to a tiny extent giving H plus and OH minus ions. First thing, water is not good conductor for electricity. It's conductor but not that much. Okay. In order to make water a good conductor for electricity, dilute sulfuric acid is added to water, which gives you H plus or H3O plus and SO4 2 minus ions in water. These free ions conduct electricity and speed up the electrolysis of water. Actually, water is not good conductor for electricity. To make it a good conductor for electricity, we have to mix this. Okay, so the reaction becomes fast. Okay. Okay, look, during this reaction, suppose I am setting up this experiment. Okay, I'm telling you, I am not leveling anything, not leveling anything. Telling you, find in which in cathode or anode which gas is formation you have to find. Now by looking this, you conclude that, sir, hydrogen is created at cathode and oxygen is created at anode. This is observed, but how you know? When you do the when you do the reaction, you have to observe two things. Look, how you find where oxygen is creating, where hydrogen is creating. How you know? Okay. So look, what will happen if burning candle is brought close to the mouth of the test tube? Mouth of the test tube means, look, this is two test tube. One is anode, one is cathode. So when you take one candle near to the cathode and anode, what will happen? Okay, what will happen? So look, when we bring a glowing candle close to the mouth of one of the test tubes, the gas in the test tube takes fires and burn with a pop sound, showing the presence of hydrogen in the test tube. What happening? Suppose this is the test tube number one, test tube number one, and this is the test tube number two. This is cathode, this is anode. To know which gas is evolving, when you took one burning candle near to the cathode, what you will observe? A pop sound. A pop sound. Okay. And the candle, the burning candle. Okay. What happening? You will listen one pop sound that's showing the presence of a hydrogen, and the fire goes down. Okay. Because hydrogen is combustible but not a supporter of a combustion. Means hydrogen can be burned, but hydrogen not the supporter of a combustion. Okay. So look, when you took a burning candle near to the cathode, you listen one sound and the flame is close. Why? Why this is happening? Because hydrogen gas is releasing. Hello, hello.
Ah, yes.
So hydrogen is combustible but not a supporter of a combustion. That's why you heard the sound and the flame
Hmm.
goes down. Okay.
Okay.
But what happening when you took this candle near to the test tube that releasing oxygen? You know oxygen is a good supporter of a combustion.
Hmm.
Mouth of another test tube, the candle start to burn brightly. Here, here, burning stuff. Here, burning stuff with a sound. With a
Sound.
sound. Why? Because hydrogen is combustible. Hydrogen can burn, but it is not the good conductor of a supporter of a combustion. Okay. But here, what happening? The the candle burns brightly. Means suppose this is the burning. They glow more. Okay. Showing the
Hmm.
test tube contain oxygen. Why it is burning rapidly? Because oxygen not combustible. Oxygen cannot burn, but it is a supporter of a combustion. Okay.
Okay.
You have to remember two conditions. Number one, when you took burning candle in the test tube that showing the presence of hydrogen, here what happening? You will hear one sound and the flame blooms up. Okay. Why? Because hydrogen is combustible but not a supporter of a combustion. आग बुझ
Okay.
जाएगा, एक आप एक साउंड सुनोगे, आप बुझ जाएगा, जो आग है वो बुझ जाएगा. क्यों ऐसे हो रहा है? क्योंकि हाइड्रोजन इज ए कंबस्टेबल. हाइड्रोजन कैन बर्न, हाइड्रोजन खुद से जल पाएगा, बट ये कंबसन को सपोर्ट नहीं कर पाएगा. ओके.
Okay.
बट व्हेन यू टुक, जब आप कैंडल को वो सेकंड वाला बर्निंग जो सेकंड वाला टेस्ट ट्यूब के पास लाओगे, क्या होगा? जितने तेज से वो जल रहा था उससे तेज जलेगा, क्योंकि दैट कंटेन ऑक्सीजन. यू नो ऑक्सीजन इज ए सपोर्टर ऑफ अ कंबसन. इट इज नॉट हाइड्रोजन नॉट सपोर्टर ऑफ अ कंबसन. दैट्स वाई वो आग बुझ गया. ऑक्सीजन इज सपोर्टर ऑफ अ कंबसन. दैट्स वाई यू सो बर्न ब्राइटली burning. Okay.
Okay.
Then comes to next photolysis or photolytic decomposition. We are learning decomposition reaction. Means single reactant gives you products. We already complete in presence of heat, in presence of
Heat.
electricity, here in presence of sunlight. What happening? Look,
Hmm.
when you bring silver chloride, AgCl is nothing but silver chloride, which is a solid in a whose state is solid. It is a white color substance. When you bring it near sunlight, it gives you silver and chlorine. Silver and chlorine. Silver is gray in color and chlorine is a green yellowish vapor. Okay. So look, one reactant, one compound, reactant one break down into
So.
many products. Same thing. When you bring silver bromide, this is silver chloride, this is silver
Hmm.
chloride. You have to remember this is solid, this is gas, and you have to balance it also. Okay.
Okay.
This is silver bromide, silver
Profile.
bromide.
Roman.
This is yellowish in color, yellowish in color. When you put this in front of a sunlight, it gives you silver and bromine. And you remember bromine is only one non-metal that is in liquid form, but here I am writing gas because
Hmm.
you are providing sunlight na.
Hmm.
Okay. And this bromine is reddish brown in color and silver is gray in color. You have to remember these two are the reaction that require sunlight to break down into many products. Okay.
Okay.
Then the second question is, all all decomposition reaction endothermic? Endothermic means observe heat. What are you thinking? heat or sorry observe energy, not only heat, observe energy. Look, in every reaction you look first, if you look thermolysis of hydrated ferrous sulfide, the reaction is observing heat. Then in the second thermolysis of a calcium carbonate, here also we give heat, that means reaction observe heat energy.
Hmm.
In thermolysis of a lead nitrate also, look, it observe heat energy.
It absorbs.
Thermolysis of copper nitrate also observe heat energy. Electrolysis of water observe electricity. All are cases observing the energy. That means yes, all decomposition reaction are endothermic because energy is given majorly in form of a heat, but electricity, sunlight or sound are also considered. So to do this reaction always we require heat or light or electricity. That's why all are endothermic. Okay, they require this thing. In this reaction never this heat or a light or electricity energy will be released. No, they consume, they don't release. Okay,
Hmm. Okay.
then the second one is a displacement reaction. Look, till now we completed two. One is combination or synthetic reaction, second one is a decomposition reaction. Combination are up to three types. One is element plus element to give a compound, compound plus compound to give a compound, element plus compound to give a compound.
Uh,
We cover these two. The third one is not in your syllabus. In decomposition reaction are of three types. One is thermolysis, second one is uh,
okay.
photolysis, and electrolysis. We complete this. Then come to displacement reaction and etc. type. First we have to understand reactivity. Reactivity. If you don't understand reactivity, then we can not able to do the things. Just a minute, 1 second. Reactivity means, look, when what is the meaning of a reactivity in terms of a metal and non-metal? When I telling reactivity of metal, what does it means? When I'm telling reactivity of a non-metal, what does it means? Okay.
Hmm.
So
Okay.
in case of a metal, if I am telling A is more reactive than B, if I am telling A is more reactive than B, what does it means? A can easily donate electron as compared to B. Okay. In
Yeah.
case of a metal, I am saying A is more reactive metal than B. That means A can easily
Done.
donate
Elect.
electron as compared to
B.
B. But if I am telling A is more reactive non-metal than B, that means A can easily accept electron as compared to B. Look the difference. Here donate means metals are donating electron, non-metals are accepting electron. But here the concept is reactivity. Suppose A is a metal, B is another metal, and I am telling you A reactivity is more than B. What does it means? A can easily release electron as compared to B.
Oh.
But suppose A is a non-metal, B is another non-metal. If I am saying A is more reactive non-metal than B, the meaning is A can easily accept electron as compared to B. Okay,
Ah.
look, a chemical reaction in which a more reactive or reactive element, more or less reactive element displace a, sorry, a chemical reaction in which more active, just a minute wait.
ମାନେ ମୋ ଥୁଆ ହେଇଛି ୟୁରି କରିଦିଅ। ଏଇଟା?
Look the definition. Hello. Look the definition. A chemical reaction in which a more reactive element or reactive this more reactive element displaces a less active or reactive element from etc compound. These reactions are generally found to occur in the solution. Okay, what do you mean by displacement reaction? A reaction in which more reactive element displaces less reactive element from etc compound. So this is called a displacement reaction. Generally this happens in solution. Solution means water. Okay, so here three types are there. One is metal metal displacement, another is metal non-metal displacement, and another one is non-metal non-metal displacement. Okay, displacement means it is a type of reaction in which more reactive element, more reactive or more active or reactive, more active or reactive element displaces a less active or reactive element from a compound. Suppose A is a element, BC is a compound. Here the in product this A is remove this B and attached with C. This is called displacement because A is more reactive than B. That's why they remove B from the compound and attached with C. Okay, so it may be metal metal displacement, it may be metal non-metal displacement, it may be non-metal non-metal displacement. Okay, it is of three types, but this is not on syllabus, so we have to learn metal metal and metal non-metal. Okay,
Okay.
so look, before starting this we have to look the reactivity order of metals. Reactivity order, this table you have to remember, otherwise you never do the reaction. Look, calcium, sodium, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, platinum. These are the reactivity order. Look, if you come top to bottom, the reactivity decreases. Means if I tell you, if in between copper and sodium, which has more reactivity? Copper, because it is placed in the top of the table. Okay, reactivity means we understand na, tendency to easily lose electron. That means potassium can easily release the electron as compared to sodium. Okay, sir, all are look, these all are metal. Why you write hydrogen? Because hydrogen have a great tendency, it can gain electron, it can lose electron, it can share electron, but metal can only lose, non-metal can only accept, but here gain, lose, share. That's why we are putting here. Okay,
Okay.
so you have to remember this, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, platinum. So otherwise you never do. Look, the given table contains metal on the basis of a reactivity of a metal with oxygen and water in terms of easily giving the electron, that is reduce other calcium lies above sodium. Okay, this is the reactivity order of metals, reactivity series. Let's do the reaction. Look, three types: metal metal displacement, metal non-metal, non-metal non-metal. So in this, in your 10th class, this is not in your class. So first look, metal metal displacement reaction. Look how to represent displacement reaction. A is a metal, BC is a ionic compound. Ionic compound means that forms by the help of a metal and non-metal, metal and a non-metal. So look, here A is a metal, BC is a ionic compound. Ionic, hello,
Hello, sir.
ionic compound. Ionic compound means in BC, B is a metal, B is a metal, C is a non-metal. C is a non-metal. Look what happening. Here A replaces B. Here A replaces B. Attached with C. Attached with
C.
C. Why this is happening? Because the reactivity of A is greater than B. That's why A replaces B. A replaces B and attached with C. Okay.
C. Okay, sir.
Look one example. Look one example. Copper plus
Huh.
ferrous sulfate plus ferrous
Sulfate.
sulfate. Look, this reaction mostly happening in solution. That's why we are writing here aqueous. Okay. When copper, which is solid, which is a metal, which is a
Metal.
metal, react with the ferrous sulfate. In ferrous sulfate, Fe, iron is a metal, iron is a, it is a ionic compound. Fe is a metal, sulfate is a non-metal. Sulfate is a,
Non-metal.
what happening? What are you thinking? First, remember, whose reactivity is greater? Copper or iron?
Copper.
Think. Whose reactivity? Because if you don't remember this, look, iron has more reactivity than copper.
Okay.
So depress possible if copper having larger reactivity than iron, but it is not happening. So here no reaction. Here no reaction. What is the reason? Because reactivity of iron is greater than copper. Displacement happening if copper having greater reactivity than iron. Here no, so no reaction. So how to write no reaction in science? First suppose you think the reaction is happening. So copper remove iron to form copper sulfate plus iron. Then put one cross mark. Put one cross mark. Otherwise write down that no reaction. Okay. Then look the second one. Zinc. In place of a copper, I am taking zinc. Zinc plus ferrous sulfate, which is a light green color. Okay. It will give you zinc sulfate. It is a colorless salt. And iron, silver clay. Look, why here displacement reaction is happening? Because reactivity of a zinc is
Zinc.
greater than iron. Is greater than iron. If you look, check reactivity of a zinc. Zinc is coming here
Hmm.
and iron is below zinc. So who having greater reactivity? Zinc. That's why zinc remove iron from the compound and make their own compound. Okay.
Okay, sir.
Then look, same for here. Lead, silver gray color. Okay.
Huh.
React with copper chloride, which is blue green. Aqueous, look, always aqueous. The solution is aqueous because most of the displacement reaction happening in a aqueous solution. Look,
Question.
in the definition also we mention in the solution. That's why every time we are taking, look, here aqueous, iron sulfide aqueous. Here we are taking copper chloride aqueous. Aqueous means dissolved in water. Silver nitrate aqueous. Okay.
Huh.
Look, lead, copper chloride. It is ionic compound. It is ionic
Compound.
compound. In ionic compound, we always write metal first, then non-metal. Whatever. Think, lead and copper. Who having larger reactivity? Lead and
Lead.
copper. Lead and copper. I don't ask about iron. Lead and copper. Reactivity of lead is greater than copper. That's why reaction is happening. This chlorine, this lead attached with the chlorine to form lead chloride and copper oxide remove. Okay. If you don't remember the reactivity order, you never complete this reaction. You have to remember the reactivity order. Okay.
Huh.
Same thing. Look, copper plus silver nitride. Same thing. Silver is replaced by copper to form copper nitride plus silver because reactivity of a copper is greater than silver.
Hmm.
You understand?
Yes.
Look, three types of displacement reaction are there. Metal metal displacement means one metal displaced displace another metal from the ionic compound. Another example is metal non-metal means one metal displaced another non-metal. Look the example, and this is not in your syllabus.
Not in a syllabus.
Look, observe the reaction between zinc and a dilute hydrochloric acid. Look, zinc, which is a metal. Dilute hydrochloric acid means HCl.
Concentrated.
Diluted means the if you
More
concentrate
concentrated.
concentrated means
Concentrated.
more acid particle. Diluted means less acid particle. Look,
Hmm.
if you remember the reactivity zinc diluted hydrochloric acid
Huh.
HCl.
HCl.
If you remember the reactivity order, zinc has more reactivity than hydrogen. Okay, so zinc replace hydrogen to form zinc chloride plus hydrogen gas. Look here, one metal displaces one non-metal. Zinc is a metal and hydrogen is a non-metal. Okay,
Hmm.
so it comes under metal non-metal displace reaction. Okay,
Okay.
then come to there is a test in your book. There is a test in your book. Take
Book.
take four beaker and label them. You have to take four beaker. Okay, label them means A, B, C, D. Put
Hmm.
25 milliliter of water in A, B, C beaker and copper sulfate solution in beaker D. First three beaker take water, 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 water. But in fourth beaker sulfate solution.
Sulfate. Sulfate.
Copper sulfate solution means CuSO4. Water with CuSO4. Okay.
Hmm.
Measure and record the temperature of each liquid contained in the beaker above. Add two spatulas of potassium sulfate, ammonium nitrate, anhydrous copper sulfate.
Okay.
Okay. In beaker A, add potassium sulfate means K2SO4. Okay.
Hmm.
In beaker B, add ammonium nitrate NH4NO3.
No.
In beaker C, anhydrous copper sulfate. Hydrous means with water, anhydrous means without water. CuSO4. And lime iron. Put iron in the fourth beaker. Okay.
Okay.
Finally, measure and record the temperature of each of the mixture. Look, in beaker A, water with the potassium sulfate. Water with the potassium sulfate.
Sulfate.
In beaker B, water with the ammonium nitrate. So these two are endothermic. These two are endothermic. Means when you touch the beaker, you feel some hot. After the after sorry, you feel some cold because it is endothermic. Endothermic means it absorb the uh,
Hmm.
no, it absorb the temperature from the surroundings. C is exothermic. C is exothermic. Look how you observe. After doing this, after doing this reaction in beaker 1, water plus potassium sulfate. This beaker, you feel some cold. ठंडा थोड़ा feel करोगे. This is also cold. This is hot. Cold means it observe the temperature. So observe the temperature means endothermic. Hot means it release heat. Release heat means exothermic. And in group D, displacement reaction will be happening. How? In group D, what you took? Iron,
Hmm.
plus copper sulfate. Iron plus
Okay.
copper sulfate. Copper sulfate. It gives you iron sulfate because iron has a more reactivity than copper, and copper is released. It is displacement reaction and it is exothermic. It is exothermic means heat is released.
Released.
First to endothermic, first to endothermic, last to exothermic. Okay, endothermic means
Say
uh,
like
observe heat, observe.
heat.
Exothermic means
Release
release heat, release heat.
heat.
With this we completed displacement. Such a easy things, only you have to remember the reactivity series. Okay.
Okay.
Double displacement. Double displacement means what? A chemical reaction in which there is an exchange of ions, that is cations and anions between reaction. Look, AB ionic compound, CD ionic compound means one cation, cation means positive ion,
Hmm.
one anions, one anions.
Alright.
Same here also cations, here also anions. What
Alright.
happening? What happening? The cation A, look, combine with D anion of the second one. The first cation attached with the second anion, and the second anion connect with the, sorry, first anion connect with the second anion. Are you looking?
Yeah.
That means A, B plus C, D. So what product you get? AD plus BC plus B, sorry, CB. Because in ionic compound always you have to write cations first. Okay.
Hmm.
So double displacement also three types. Double displacement also three types.
Three times.
You remember double displacement? Exchange of ions. Exchange of
Iron.
ions. Precipitation reaction, neutralization reaction, gas forming reaction. These two you read in acid, base and salt chapter.
Hmm.
Neutralizing means when one acid react with the base, give you
Base.
salt. It is a neutralization reaction. This is not in your first chapter. These two are in your second chapter. Precipitation reaction you have to read.
Okay.
Look, the reaction in which aqueous solution of a two ionic compound or a gas and aqueous solution of ionic compound react to form an insoluble solid of precipitate. You know precipitate. Precipitate means not dissolve in
Not
water,
dissolved.
not solid. Create after, create
After.
after reaction, after chemical reaction, and it is insoluble. It is insoluble solid. Insoluble
Solid.
solid. Look what happening here. This one. Okay. Solution of two ionic compound of react to form insoluble. Look, this react with this. This is nitrogen monoxide trioxide. Nitrogen
Trioxide.
trioxide react with the potassium iodide. Potassium.
Iodide.
Oh, it is lead nitrate. Lead nitrate. Sorry, the reaction is not complete. I have to write. Just wait. This is lead nitrate. Okay, lead nitrate. Lead
Nitrate.
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 Nitrate react with the potassium iodide.
Iodide.
Potassium
Iodide.
iodide. Look, in lead nitrate, Pb is cation. Pb is cation.
Cation.
Nitrate is anion.
Hmm.
Here K is cation. I is anion. So what happened? Look, Pb remove this K to form lead
Iodide.
iodide, and this K react with nitrate to form potassium nitrate. Potassium nitrate.
Nitrate.
Are you looking the changing in ion?
They change in
Ion.
iron.
Yeah, these two are colorless, and this color is yellow, and it is precipitate. Precipitate means colorless solution. Lead nitrate and potassium iodide, both are dissolved in water. But lead iodide is a solid precipitate, and potassium nitrite, it is aqueous, colorless solution. You understand this reaction? Look, I am writing again. Pb, lead nitrate, lead nitrate. In lead nitrate, Pb is a cation, nitrite is a anion. Okay, plus Ki means potassium iodide. K is anion, I is a cation. Sorry, cation anion. What happening? Look, Pb react with the I to form lead iodide. Why I am writing 2 here? Why these all are the concept of ninth class to make the valency. To make valency clear. Okay. You know na in ninth class in chapter number 3 I think. Here there the formula to how to write the balancer interchanged. Then potassium nitrite. Potassium nitrite. This is nothing but one example of here you have to write Pb. Pb is missing. One example of a precipitate double displacement reaction. Okay.
Okay, sir.
Then the question is, can double displacement reaction happen in solid state? Look here, in any cases we are take solution. Look, it is aqueous. Aqueous means dissolve in water. Dissolve in water. Here also aqueous. So can it possible to make double displacement in solid state? This type of a reaction is called a mechanochemical reaction. When double displacement reaction happening in solid state, it is called mechanochemical reaction. Okay, where the ions are exchanged on supplying input energy by shaking. When you same thing you do in form of solid. Look, suppose I am taking lead nitrate solid form. Okay, and potassium iodide also solid form. When you shake means you provide energy, then this is forming. Means it can be easily observed in aqueous solution, but in solid also it's possible. Okay.
Okay.
Look, take about 2 gram barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Look, this is barium hydroxide. Okay. This is ammonium chloride. So double displacement will be happening. Ba react with a chlorine to form barium chloride, and this NH4 react with a hydroxide to form ammonium hydroxide. Ammonium hydroxide. So it is a exothermic reaction. Okay, remember, if you do the reaction in your school, you will understand it is a endothermic reaction. Endothermic reaction. Endothermic means release energy, release or consume.
Release.
Exothermic means release, consume. How you understand? There is a test in your school, they will conduct, you will understand. Okay. This is the reaction. Barium chloride, it is another example, I think. Leave it. Come to introduction to redox reaction, last portion of your chapter. A chemical reaction in which reduction and oxidation. Reduction means what? Oxidation means what? I will tell you. Just wait. Takes place simultaneously. Remember, redox is a chemical reaction. Under these two types of reaction are happening. One is reduction, one is a oxidation. And remember, when redox reaction will be happening, these two reactions are happening simultaneously. Means side by side hoga. Okay. Redox is a chemical reaction in which reduction and oxidation. Till now we don't know what you mean by reduction, what you mean by oxidation. But if you remember, when we are teaching the photosynthesis, that time I was telling you reduction of a hydrogen with carbon dioxide to make glucose. Remember? So what do you mean by redox? To understand redox method, to understand redox chemical reaction, first we have to understand reduction and oxidation. Okay, then come to redox. Look, oxidation means addition of oxygen or removal of hydrogen. Okay, oxidation reaction means addition of oxygen on or removal of hydrogen. Okay, reduction means addition of hydrogen, removal of oxygen. Clearly look it. Oxidation means addition of oxygen, removal of hydrogen. Reduction means adding of hydrogen, removal of oxygen. Okay, here plus symbol is in oxygen, here in hydrogen. Here minus symbol is in hydrogen, here minus symbol in oxygen. You understand or not? Tell me.
Understand.
So
Like,
the yeah, tell me.
when they
Look, we'll give example. You will understand. Redox means addition or removal of a hydrogen or oxygen. You will understand a redox reaction by two methods. Look this or look this. This is not now. Only this means how we know reduction reaction is happening or not. Redox means two chemical reaction are there. Reduction, oxidation. You understand reduction means what? Adding of oxygen or removal of hydrogen. Or from a compound, if oxygen is adding, from a element or a compound, if oxygen is adding, this is called a oxidation reaction. Or from a compound or element, if hydrogen is subtracting, that is called the oxidation. Two condition, adding or subtracting. Come to the example. Look, copper oxide, which is black in color, when react with zinc, it is a double displacement reaction. That means zinc has a more reactivity than copper. So what did you form? Zinc oxide. What is it form? Zinc oxide plus copper. Okay, you remember? Look, the copper oxide, left to right hand side. Don't look right hand side to left hand side. To know reduction and oxidation reaction, always you have to remember. Look left hand side to right hand side. Okay, look copper oxide. It gives you copper. Then look here, removal of oxygen happening or addition of oxygen happening.
addition.
From copper oxide to copper, here addition is happening.
Addition.
How you say here addition? From copper oxide to copper, from copper left to right hand side. In left hand side copper oxide is there, but in right hand side copper, how copper become? Because subtraction of oxygen na. You remove oxygen. Remove oxygen means reduction.
Reduction.
Look, two things I am writing here. Oxidation means and reaction. Oxidation means adding of oxygen. Reduction means subtracting of oxygen.
Oxygen.
Oxidation means subtracting of hydrogen.
Hydrogen.
Reduction means addition of hydrogen.
Hydrogen.
So look what is here happening. Subtraction of oxygen na. Subtraction of oxygen comes under reduction na.
Reduction.
And remember, reduction and oxidation both happening simultaneously. Simultaneously means side by side. Look, zinc to zinc oxide. Here what happening? Adding of oxygen na.
Yeah.
Adding of oxygen, it means oxidation. You understand or not? Tell me.
Understand.
Okay, oxidation reaction completed. Look, then two terms are there: oxidizing agent or oxidizing agent or oxidant, reducing agent or reductant. What does it means? Look, how to know which one is a oxidizing agent in the reaction and which one is the Reducing agent or reductant? How you know? Look, how you know? Oxidize other and itself get reduced. Simple सा meaning, ऑक्सीडाइज अदर्स, वो सामने वाला को ऑक्सीडाइज करेगा. ऑक्सीडाइज मीन्स एडिशन ऑफ ऑक्सीजन और रिमूवल ऑफ हाइड्रोजन. खुद खुद रिड्यूस हो जाएगा. ओके, टेक वन एग्जांपल, यू विल अंडरस्टैंड. लुक, कॉपर ऑक्साइड, सेम एग्जांपल, प्लस जिंक. कॉपर प्लस जिंक ऑक्साइड.
Zinc oxide.
Look, here copper oxide reduced to copper
Copper.
because subtraction of oxygen, and Zn oxidized, Zn oxidized to form ZnO because addition of oxygen. So suppose I am asking about who is the oxidizing agent, who is the reductant agent. Look, addition of oxygen means oxidation,
Yeah.
so reductant. Removal of oxygen means reduction, oxidizing agent. Just write in the text. So here look, copper oxide reducing to copper, so the remaining here zinc is the oxidizing agent. Okay,
Okay.
just a minute. Removal of oxygen, reduction, no, copper oxide to copper, this is removal of oxygen, means reduction. So here copper oxide is called, look, alternative in which here reduction is happening from copper oxide to copper. Here removal of oxygen means reduction, and this copper oxide is called the oxidizing agent. It's called oxidizing agent, means where reduction is happening, that is called oxidizing agent. Where oxidation is happening, that is called a reductant agent. Okay, so you look, copper oxide reduction is happening because subtraction of oxygen, so this copper oxide is called the oxidizing agent. Only alternative, where reduction is happening, that time you tell that compound that is oxidizing agent. Where always find from right side, don't come to left side. Okay, here copper oxide is removing oxygen, so it is a reduction reaction, and this copper oxide is called oxidizing agent. Okay,
Okay.
zinc is oxidized to give zinc oxide, so zinc is called reductant agent. Okay,
Okay.
don't be confused. Look this reaction. Magnesium dioxide, when react with hydrochloric acid, it gives you magnesium chloride plus water plus chlorine. First check the reaction. Look the left hand side. Magnesium oxide gives you magnesium chloride. Magnesium oxide gives you,
Magnesium chloride.
then what is happening? Oxidation or reduction?
Oxidization.
Oxidation means what? Adding of oxygen or removal of hydrogen. Here what happening? You forgot oxidation. Look, oxidation means adding
Oxygen.
reduction means removal of
Oxygen.
so here what happening? Adding of oxygen or removal of oxygen?
Removal of oxygen.
Removal of oxygen means
Reduction.
reduction. Then look, hydrochloric acid. Look what happening. Again you are telling reduction. Removal of hydrogen is called oxidation, and adding of hydrogen. So here what happening? Removal happening or adding happening?
Adding.
From hydrochloric acid to chlorine, you are adding. Where is the hydrogen in right hand side? Removing, na?
Confused. Removing, sir.
Okay, don't be confused. First look. Oxidation and reduction reduction.
Reduction.
Oxidation means adding of oxygen, adding of
Oxygen.
or remove of hydrogen or remove of
Hydrogen.
so look, magnesium oxide gives you magnesium chloride, and that side I am writing reduction. Subtraction of oxygen or adding of hydrogen. Are you looking?
Yeah.
So tell me, here what happening? Subtraction of oxygen or addition of subtraction? Addition of oxygen. Magnesium oxide gives you magnesium chloride. Here oxygen add हो रहा है. लेफ्ट टू राइट हैंड साइड देखो, लेफ्ट में ऑक्सीजन था, राइट में ऑक्सीजन नहीं है.
नहीं है.
दैट मीन्स क्या हुआ है? सब्ट्रैक्शन. दैट मीन्स क्या हुआ है? Subtraction of oxygen. Then subtraction of oxygen is comes under reduction, na?
Yeah.
And then look, hydrochloric acid, 2 chlorine. Here क्या हुआ है हाइड्रोजन का? एडिशन और सब्ट्रैक्शन? लेफ्ट टू राइट. लेफ्ट में हाइड्रोजन था, राइट में हाइड्रोजन नहीं है, तो ये एडिशन है या फिर सब्ट्रैक्शन है?
Subtraction. Reduction.
सब्ट्रैक्शन ऑफ हाइड्रोजन. सब्ट्रैक्शन ऑफ
Hydrogen.
तो सब्ट्रैक्शन ऑफ हाइड्रोजन किस में आ रहा है? ऑक्सीडेशन में ना.
Removal of hydrogen. Yeah. Oxygen.
So this MnO2 is your reductant agent. Is your reductant agent because oxide. Oh, just a minute. Here reduction is happening. MnO2 reduction is happening, na? So it is called oxidizing agent. Opposite. Here hydrochloric acid oxidized, so it is called reducting agent. You understand or not?
Understood.
Having a doubt here?
No, got it.
Then look, that is a. And remember, 1000 times I am telling, this reduction and oxidation happens side by side. Don't think there is any reaction in which or reduction is happening and oxidation is not happening. No, side by side this is happening. Look, few in the starting of the class we have did one reaction, that is magnesium plus oxygen gives you magnesium oxide. Okay. Then tell me, I am balancing the reaction. Okay. Look, you tell me, magnesium to magnesium oxide. Here oxidation or reduction? Don't be confused. Look it carefully. Then tell me. ऑक्सीडेशन का मीनिंग क्या है? ऑक्सीजन का आड़ होना या फिर हाइड्रोजन का रिमूव होना. सो इधर मैग्नीशियम से मैग्नीशियम ऑक्साइड में क्या हुआ है? हाइड्रोजन का ऑक्सीजन का आड़ हुआ है या फिर हाइड्रोजन का रिमूवल हुआ है? लेफ्ट टू राइट हैंड साइड. मैग्नेस अरे लेफ्ट टू राइट यार, लेफ्ट टू राइट. मैग्नीशियम में ऑक्सीजन था नहीं था? हियर आड हुआ है ना. सो एडिशन ऑफ ऑक्सीजन इज कॉल्ड एडिशन ऑफ ऑक्सीजन. ऑक्सीजन ऑक्सीडेशन और रिडक्शन?
Addition of oxygen is oxidization.
Oxidation. Look, oxidation means add oxygen. First to look carefully, then we will go move to add oxygen, subtract hydrogen. Okay. Reduction means add hydrogen, subtract oxygen. You understand this? Then look here, why you are confusing here, I don't understand. Look here, we have to go left hand side to right hand side, left hand side to right hand. if लेफ्ट हैंड साइड मैग्नीशियम था, ये क्या दिया, मैग्नीशियम ऑक्साइड. दैट मीन्स लेफ्ट हैंड साइड में मैं क्या किया, मैग्नीशियम ऑक्साइड पाने के लिए ऑक्सीजन को ऐड किया.
Yeah.
तो ऑक्सीजन ऐड मीन्स ऑक्सीडेशन. ओके.
Okay.
और ये मैग्नीशियम क्या होगा, रिडक्टिंग एजेंट, बिकॉज उल्टा ना. देन कम टू ऑक्सीजन. लेफ्ट हैंड साइड में O2 था, राइट हैंड साइड में O है.
Oh.
किससे अब दो O2 से एक O2 आपको मिल गया, एडिशन हुआ है ऑक्सीजन का या फिर सब्ट्रैक्शन हुआ है ऑक्सीजन का. दो रुपीस आपके पास था, अभी आपके पास 1 रुपी है. हाउ यू गेट 2 from 1? Subtract of 1. That means here subtract of oxygen. Subtract of oxygen means reduction. Means
Sir, magnesium is oxidized.
yeah, because
Oxygen is reduced.
oxygen is reduced and O2 is called the oxidizing agent. Who reductant? In where reduction is happening, there you have to find oxidizing agent. Okay, you understand or not? Tell me.
No, got it.
Yes. Then come to second. Think and tell me. Copper plus oxygen. Remember, ये ऑक्सीजन, नाइट्रोजन, ओके, इन लोग के साथ जितने भी मेटल है ना, ये रिएक्ट कर जाएंगे. दैट इज कॉल्ड कोरोजन. हम पढ़ेंगे टू फॉर्म कॉपर ऑक्साइड. ओके, नाउ लुक, कॉपर पहले था, नाउ इट फॉर्म कॉपर ऑक्साइड. कैसे बन गया, एडिंग ऑफ ऑक्सीजन और सब्ट्रैक्टिंग ऑफ ऑक्सीजन.
Copper is oxidized.
ऑक्सीडाइज्ड.
Oxygen is reduced.
ऑक्सीजन था, अभी एक ही ऑक्सीजन, CuO में एक ही ऑक्सीजन है तो रिड्यूस्ड. सो हियर कॉपर इज द reductant agent, oxygen is the oxidizing agent. You understand or not? Then effect of oxidation in daily life. Oxidation means ये जो adding of oxygen और subtraction of hydrogen है, it has lots of things in our daily life. Okay, what happening? Number one, corrosion. Number one, corrosion. Corrosion is such a means disadvantages to the metals. Look, metals have a property to shining the surface, shining the surface. Think about gold. Gold is shining na. Think about silver, shining na. Copper, aluminum. Suppose you buy one new bike, the iron are shining na. But after few days, they have one reddish brown color in iron, reddish brown color coating. That is called rusting. This rusting is nothing but a type of a corrosion. A type of a corrosion. You want or don't want, this reaction will be happen because it requires only oxygen. Okay, look what happening. Corrosion. It is a surface of a degradation process of a metal in which they convert to a more stable form, that is oxidized sulfide carbonate, and more due to the attack of atmospheric gases. What does it mean, sir? I don't understand. Tell me. Okay, there is a metal. Remember, there is a concept called stable form. Hello. Yeah, there is a concept called stable form. Stable form means, look, metals always ready to give electron. Non-metal always ready to they give electron. Non-metal ready to accept electron. Why they give, why they get? To form stable, electrically stable. This is why metal means ready to get electron, and in air we have different types of non-metal like oxygen, like sulfur, like carbon. So they react with it. So the metals react with this oxygen, sulfur or carbonate to become stable. Due to this corrosion is formed. Corrosion means degradation. The property through which metal react with the oxygen, sulfur and carbon to become stable. Due to this degradation start, this degradation is now called corrosion. Okay,
Okay.
you want or don't want, this corrosion reaction automatically happen. That's, look, one of the example is a type of corrosion. Corrosion are of several type. One is rusting. What is it?
Rusting.
Rusting. Name of name rust. Color of the layer reddish brown. Look, the process is called rusting. Name rust. Look, this is the iron, this is silver, this is shining surface. Look, this is rust. Okay,
Yeah.
this corrosion have advantages and disadvantages and disadvantages.
Disadvantages.
Look, first we are learning disadvantages. Rust is a flaky non-sticky layer that is very brittle and peels up. Peels up means ऐसे एक से के नीचे खींच जाएंगे.
Yeah.
फर्स्ट एक लेयर बन जाएगा, लेयर नीचे खींच जाएगा, फिर जो आयरन डायरेक्ट एयर के कांटेक्ट में आएंगे उसके ऊपर भी ये स्टिकी फ्लेकी नॉन स्टिकी लेयर दैट इज वेरी ब्रिटल. ब्रिटल मीन्स दिस इज शाइनिंग सरफेस, दिस इज ब्रिटल सरफेस. पिल्स अप मीन्स नीचे खींच जाना. It then expose the fresh iron layer to moisture and oxygen. This continuous cycle make iron object weak and can collapse building and a bridge, break oil pipelines and more. Okay, are you looking?
Yeah.
So iron react with the oxygen and water, form a flaky non-sticky layer that is called a iron oxide or a rusting. Due to this our iron object become weak. Okay,
Okay.
then come to types of another corrosion called tranishing. Look, rusting found over iron,
Iron.
but tranishing found over copper. Rusting have a disadvantages that weak the iron object, but tranishing provide advantages to green to copper. Look, this is a statue of liberty. This is the real copper and this is the tranishing. Due to tranishing have advantages. It provide advantages. Look, it is called patina. And the color is called green. Look, the type of corrosion is tranishing. Name of the outer covering is called patina and the color of layer is green. Patina seems to be helpful for some of the metals like copper, which on oxidation forms an impervious protective layer that protect further corrosion. Here tranishing of better. ये क्या करेगा, ऐसे ग्रीन कलर का लेयर बना देगा और it is sticky to the surface. It is not like rust. Rust peels off. It does not peel off. Okay.
Okay.
Then look, tranishing is also found on a silver.
Silver.
Patina, it is black. Here it provide disadvantages. Look, it is the silver lost their shining surface na.
Yeah.
Last concept, that is rancidity or rancidification. It is the oxidation of oil and fat containing food item when they are kept in the open for a long time, resulting in an unpleasant odor and taste. When you keep oil or fat, suppose you kept chicken curry in open air, after some time it is unpleasant odor. The smell becomes unpleasant and taste also become unpleasant. Why this is happening? Due to this reason, oxidative rancidity. This is the process. Okay. If someone asks what is rancidity, so rancidity is nothing but it is the oxidation of oil and fat containing food item that kept for a long time in open area, resulting in unpleasant odor and taste. Okay. So this rancidity happening here due to oxidative rancidity. But microbes also are there. Bread mold, they also
do same thing, and hydrolytic of water also, due to these three reasons this is happening. Okay. So how to prevent rancidity? We prevent rancidity. Here are some technique. One is refrigerator. Put food inside refrigerator, फ्रिज में रख दो. फ्रिज में रखने से क्या होगा? Refrigeration lowers down the oxidation of food items and prevent a chance in their order and taste. In fridge the temperature is low na, so oxidation becomes slow. Oxidation reaction becomes slow. That prevent our food. Then second one is addition of antioxidants. In some food item, in oil and fat containing food item, vitamin C, absorbic acid, we are to remove rancidity. To stop rancidity. Okay. In kurkure packet, in cheap packets,
Yeah, they fill
they follow nitrogen. Why they follow nitrogen? To stop the rancidity.
rancid.
That's why we are using nitrogen. Nitrogen has two work, two benefit. First, it prevent the oxidation, and second, it provide the space. It provide the space pieces of cell don't break.
Huh.
Okay, this is the concept.